Hey there again, guys. We're looking at doing some more geometric proofs here because you need to practice these in order to be able to understand them and to get good at them. So the more you're able to practice, the more you're able to watch, hopefully, the better that you're able to be as you go on with these proofs. Okay, so are still some parallel line proofs. So remember, our given statement here is that we have parallel lines. So that is always the first statement that we're able to write down. Okay, and the reason we're able to write it down is because it is given to us. So the first statement is always the given statement, and the first reason is always that it's given to us. So now let's look at what we want to do. We want to show that angle 8 down here is the same as angle 4 up there. Okay, that's what we want to show, that 8 is the same as 4. Okay, and maybe you notice that these are in an alternate exterior angle position, okay, which is good because we're actually proving the alternate exterior angle theorem. It says if parallel lines are cut by a transversal, then these angles are congruent. Okay, so the way we want to do this is notice that we have angles 8 and angle 4. So we want to start by introducing or writing down a true statement, okay, a true geometrical statement with either angle 8 or angle 4 in it. So because angle 8 is on the left, I'm going to start with angle 8. Okay, so I notice hopefully that maybe angle 8 is the same as angle 6. Okay, maybe this is what you're noticing, right? 8 and angle 6 are the same because these are a pair of corresponding angles. Okay, so I'm able to write down that angle 8 is congruent to angle 6. Okay, these are corresponding angles. So then the reason is the corresponding angle postulate, which says if parallel lines are cut by transversal, then corresponding angles are congruent. Okay, so this is always true. Every time you have parallel lines, you have congruent corresponding angles. So that's a great place to start, is by finding a pair of corresponding angles. Okay, so now that we have angle 8 in our proof, okay, maybe we can do something with angle 4. So let's look and see angle 4. Maybe you notice that angle 4 is across from angle 6. And maybe this should spark some things in your brain, that these are vertical angles, right? These are vertical angles. So I can write down that angle 4 is congruent to angle 6. Okay, remember these are vertical angles. Okay. And the reason that vertical angles are congruent is the vertical angle theorem. So the reason is the vertical angle theorem. All of these things we write down over here as the reasons. Okay, 4 and 6 are vertical angles, so I can write that they are congruent because of the vertical angle theorem. Okay. Corresponding angles 8 and 6, I can write them down that they're congruent because of the corresponding angle postulate. Right? Everything that you write down, every geometric relationship over here needs to have a corresponding definition, theorem, postulate, property over there. Okay, so now let's look and see what we have. All right, I have angle 8 is congruent to angle 6. I have angle 4 is also congruent to angle 6. So 8 and 4 are congruent to the same middle angle, which means that they have to be congruent to each other. Okay, there is no other choice. If 8 is the same as 6 and 4 is also the same as 6, that means 8 is the same as 4. Okay, so these two steps allow you to make the deductive reasoning that 8 is therefore congruent to 4. Okay, and this is using something called the transitive property of equality. Okay, so this is the transitive property. And we have done it. We were asked to prove that angle 8 is the same as angle 4. We have shown through our geometrical steps that angle 8 is the same as angle 4. So we are done with your proof. So you put a little box at the end, you can color it in. We're all done. Okay. Simple, fantastic. Okay, finding this angle 6. Angle 6 is the angle that links angles 4 and angle 8. Okay, because these ones are both related to angle 6. So let's look at another one. Oh, delali. Okay, the Consecutive Interior Angle Theorem. Okay, says if parallel lines are cut by a transversal, consecutive interior angles are supplementary. So we want to show that angle 2 plus angle 3 adds up to 180. Okay, so let's go back to where we start. We always start with our given information. A is parallel to B. Okay, and anytime you want to, you can pause this, okay, and try to do it on your own, and then go back and see if you did it the same way I did it. There are a couple of ways that you can do it, and it's still correct. So if you are pausing to do it on your own and then to come back and watch it later to make sure that you did it right, that's fine. But just know that there are multiple ways to do this. So the first statement is always what we're given, and the first reason is that it is given. Okay, so now let's look at where we want to go. We want to show that angle 2 plus angle 3 add up to 180. Okay, so what we initially want to do is find, right, maybe find an angle that angle 2 and some other angle already add up to 180. Okay, so if you want to have an adding up to 180 as your final answer, let's start with some other statement that also adds up to 180. Okay, but because yellow is not very good, let's look at orange. Okay, what about these two? Okay, here's an angle that involves angle 2, okay, angle 2 and angle 1. So maybe if I write down angle 2, the measure of angle 2 plus the measure of angle 1 equals 180. Okay, that is a true statement, right? These are two angles that form a straight line. So this is the definition of a linear pair. Anytime you have two adjacent angles that form a straight line, they add up to 180 because of what a linear pair does. Okay, that's the definition. Okay, so now I have angle 2 plus angle something, right? Not angle 3 yet, but something adds up to 180. So my brain, right? My brain is thinking, okay, maybe I can find a relationship between angle 1 and angle 3, right? That's all I need to do. I already have angle 2 plus something, right? I would really like this angle 1 to be actually angle 3. So let's see if we can find a relationship between 1 and 3. So let's see. Angle 1 is right here. Okay, it's a great angle. And angle 3 is right here. Okay, also a great angle. These look familiar to me. Okay, hopefully they do to you also. Maybe you recognize these as being corresponding angles. Okay, so I can say that angle 1 is congruent to angle 3, okay, by the corresponding angle postulate, like just like we did up above. Corresponding angle postulate. If parallel lines are cut by a transversal, then corresponding angles are congruent, right? It says the word congruent, so we have to write down the symbol for congruence. Okay, now I'm really close. If I want to therefore replace, right, I want to replace angle 1, I can only replace when I have equals. So I'm going to take this congruence and write it down as equals, and I am allowed to do this. Okay, but notice how I'm writing it. Angle 1 is congruent to angle 3, but line 4 says the measure of angle 1 equals the measure of angle 3. Okay, so if angles are congruent, then their measures are equal. Okay, they're degrees, and this is using the definition of congruence. Anytime you want to change from congruence to equality or from equality to congruence, we are using the definition of congruence. Okay, and if you want to replace, right, if we want to substitute, if you want to take this and instead of having angle 1, now have angle 3. Okay, if I am ever going to replace, I can only replace once I have equals. Okay, I can't replace from congruence. That's not okay. I have to replace from equals, because when I replace from equals, I am using the substitution property. In order to use substitution, I have to have equals, not congruence. Okay, so this step is necessary in order to use substitution. because I can't replace angle 1 with angle 3 unless they are equal. Okay, congruence is good. Equals is what I need. So I can change my congruence to equals by using the substitution property. Oh, and look, I have angle 2 plus angle 3 equals 180, and that is exactly what I wanted to have. So my proof, therefore, is done. Okay, so remember, we're trying to find, right? We have a start place, and we have where we're trying to end. So we need to introduce something similar to this, okay, at the beginning, and then work throughout the proof in order to replace it with what we actually want. Hopefully this helps, and you are well on your way to being an excellent geometric prover.